So I just want to show you one example of how tides look like in an estuary, in a semi-enclosed sea. Okay, and this is Chesapeake Bay, and what's shown here is a simulation of the M2 tide. Okay, you learned about tides. This one is one tidal constituents, and what you can see here is the entrance of the estuary. Okay, it's here on the right-hand side, and the blue colors here show you the sea level elevation. Okay, as a function of time, you see in the animation, the bathymetry and the coastline you can see here and with the colors. Okay, and the vertical range is about 2 meters. Okay, we can see the tides, and the tide you have a high water here on one side, and what creates the variation of the sea level is the flow that goes into the estuary. Okay, it leads to a convergence and the sea level goes up, and where it goes down you have a divergence. Okay, so if your estuary is relatively large, you actually get a structure where, while there's a high water at one end, there's actually low water on the other end. Okay, you can get these type of forced, we call them co-oscillation tides. Okay, we heard about them before. So what the tides do in estuary is actually they provide a means of mixing. If they're very, very strong, they can actually mix away vertical salinity gradients. If they're weak, they're not. Okay, so we look at the different types of estuaries that you can have, and because of the relative importance of the tidal mixing and the amount of fresh water that you actually have in a system.